In this video, we are going to talk about forward starting loans. So a forward starting loan is an agreement for either the borrowing or lending of a principal starting sometime in the future. We're contrasting this with a immediately starting loan where we're borrowing or lending immediately. Often we are thinking in terms of a bank, and so a bank borrowing is accepting a deposit. So, for example, a bank agrees to lend $1 million for 365 days, starting in 365 days, at an actual over 360 interest rate of 3%. So we have today, we have a year in the future, and then we have 2 years in the future. A year in the future, the bank has agreed to pay out $1 million. They receive back at year 2 the interest, which is, again, it's an actual over 360 rate. So that's $1 million times 3% times 365, the number of days the lending is taking place for, divided by 360, or $30,416.67. And then, of course, they get their $1 million of principal back. If we think about the valuation for a second, and we'll take the lender's viewpoint right now, but we could take the borrower's. A loan of N dollars, the principal, from time T1 to time T2 at some agreed rate, RK, we'll often call that the strike. For actual over 360, we'll let D be the day count fraction, days 2, the days for time T2, minus days 1 divided by 360. If this were an actual over 365, we would just change that 360 to a 365. We're paying out N at time T1, we're receiving back N times RK times D. At time T2, that's the interest, plus the principal. We can value this loan given continuously compounded rates R1 and R2. Take the present value of the first cash flow, so that's negative N times e to the minus R1 times T1, plus N times 1 plus RK times D, so that's the principal being repaid plus the interest, e to the minus R2 T2. Let's work an example. So we're going to find the present value of a loan. So a bank agrees to lend that $1 million for 1 year starting in a year on an actual 360 interest rate of 3%. We're going to assume the following interest rates. The 365-day continuously compounded rate is 2.5%. The 730-day continuously compounded rate is 2.6%. We figure out the cash flows first. Take the bank's perspective. The bank is lending. The first cash flow is negative $1 million. The bank's going to receive the principal back at maturity plus interest. The interest is $1 million times 0.03 times 730 minus 365 over 360, or $30,416.67. And so the second cash flow is $1,030,416.67. We calculate the present value, knowing our interest rates. The first cash flow, negative $1 million times e to the minus 0.025 times 365 over 365, or just 1. So that's negative $975,309.91. Present value of the second cash flow, positive $1,030,416.67 times e to the minus R2 T2. That's $978,204.29. And of course, the present value of the loan is the sum of these two numbers, $2,894.38. We can take a slightly different perspective. So first, we think about the fair forward rate. So the fair forward rate, or the fair rate, RF, is the rate such that the present value of the loan is 0. We set the loan value equal to 0, and we can solve for RF. We do a bit of math, a bit of manipulation, and we get RF equals e to the R2 T2 minus R1 T1 minus 1, all divided by D. That's usually days 2 minus days 1 over, let's say, 360. So first off, we can calculate the fair forward rate. So given continuously compounded interest rates, what is the actual over 360 fair forward rate for a loan between 97 and 145 days? Again, this is simply plugging numbers into a formula. We plug our numbers in, so the formula, that's going to be RF, the fair rate, equals E to the longer dated continuously compounded rate, 0.0125, times 145 over 365, minus the shorter dated, 0.0150, times 97 divided by 365. All of that minus 1 divided by D, which is simply 145 minus 97 over 360. We have a fair rate of 0.7349. Again, because the longer dated rate is below the shorter dated rate, the fair rate is lower than either rate. Okay, what do we do with the fair forward rate? We know the present value of a loan from T1 to T2 at an agreed rate RK with day count fraction D is our formula. Present value is negative n e to the minus r1 t1 plus n times the quantity 1 plus rk times d e to the minus r2 t2. We do a lot of manipulation. I'm not going to do it here, but we do a lot of manipulation, some algebra, and we end up with PV equals n times the quantity rk minus rf times d e to the minus r2 t2. All right, what does this tell us? Forward starting loan is equivalent to an agreement where the interest at a predetermined rate RK is exchanged for the interest at the fair forward rate. All right, if we go back for a second, look at this formula, we've got RK minus RF. If I think about this, N times RK times D is the interest we've agreed, and N times RF times D is what's fair. So the value of the loan is the difference between the interest that would be paid at rate RF and the interest that must be paid at rate RK. Let's see that visually for a second. So a loan from T1 to T2 with day count fraction D is agreed at the fair rate. So RK is going to equal RF, present value is equal to 0. The interest owed is N times RK times D. That's our loan. Again, of course, there's principal exchange in this loan, but let's just think of it this way for a second. If the fair rate changes to a new fair rate, then the lender is receiving too much or too little interest. Take the present value of the difference. So the interest owed that we are owed, we're the lender. The interest that we're owed, N times RK times D. The interest that's now prevailing, N times RF times D. The interest is paid at time T2, so we have to discount it, and we get a present value as N times RK minus RF times D times e to the minus R2 T2. Okay, both of these formulas are equivalent. Sometimes it's easier to work in one, sometimes it's easier to work in the other. Let's do an example where it's easier to work in the second formula. So a bank agrees to accept a deposit, right? They're borrowing now, $1 million for 1 year, starting in 1 year, at the fair actual over 360 rate minus 0.5%. At what rate do they agree? And what's the present value of the loan? And let's assume interest rates are the ones we've been working on with maturity 365 days, it's 2.5% continuously compounded rate, maturity 730 days, 2.6% continuously compounded. So first we calculate the agreed rate. To calculate the agreed rate, we have to calculate the fair rate. So RF, that's our RF equals e to the R2 T2 minus R1 T1 minus 1 over D. Plug all our numbers in, and we get RF equals 2.6993%. We subtract 0.5% and find that RK is going to be 2.1993%. Now at this point, we could go back to the original pricing formula and use it to value the loan. Alternatively, we can use the second pricing formula, which is N times RF minus RK times days 2 minus days 1 over 360 times e to the minus R2 T2. Now notice I've done a little thing here. I've changed the sign of RF minus RK. So in the original one, we were accepting a loan, it was RK minus RF. Now when we were lending, it was RK minus RF. Now we're accepting a deposit, it's RF minus RK. What we have to be careful about is just making sure our signs are correct. Plug in our numbers, $1 million times 0.5% times 365 over 360, e to the minus R2T2. Present value is $4,812.57. And we can kind of look at this number and go, well, it should be a little bit less than $5,000. We've agreed a rate 0.5% too low, so we're paying someone else interest. We've agreed a rate 0.5% too low. That's good for us. How much money are we saving in interest? Well, about, this isn't exact, but about $1 million times 0.5%, $5,000. We're saving ourselves a little bit more because the day count fraction, again, is 365 over 360. So it's a little bit more than $5,000. Discount at 2 years, at 2.5%, 2.6%, $4,812.57.